5. So this one is Jan 2019 Unit 5. Question number 1. Chromium is classified as a transition element because. So basically, what is the definition of a transition element? The transition element, they form a stable ion with an incomplete d orbital. And this definition, because scandium and zinc does not obey or follow this definition, that's why they're not considered as a transition element. So it forms a stable ion with an incomplete d orbital. That's why D is the right answer. Then question 2. The series below shows first 4 ionization energy in different elements. Which could those be transition element? The transition element, their ionization energies are comparable. Successive ionization energies are comparable. That's why, like example, this is double, then about double, this about. So C is the right answer. Which of the following are oxidation state of a chromium in the ions shown? So chromium hydroxide with the overall charge 3 minus or minus 3. So each hydroxide is -1, so 6 will be -6. So chromium should be +3, so that the net will be minus. And chromate ion CrO4, each oxygen is -2, so 4 oxygen will be -8. So chromium should be +6, so that the net charge will be 2 minus or -2. So the first one, the chromium is +3, and the second one is +6. So B should be the right answer. Question 4. A metal M react with a nitrate in acidic condition. The product are Mn +1 and the water and the nitrogen dioxide, NO. The ratio of a M atom to nitrate ion is 3:2. What will be the value? What will be the charge? So how we can identify? The metal M, there is a metal M which react with a nitrate ion. So, and the ratio for metal atom to nitrate ion is 3:2. It produces nitrogen 2 oxide, metal ion is there, plus nitrogen 2 oxide, nitrogen monoxide we can also say, and water H2O is there. Now we'll identify the change in oxidation number for nitrogen here. Look, each oxygen is -2. Each oxygen is -2, so 6 oxygen will be -6. So because overall charge is -1, so nitrate should be nitrogen should be +5. And here in each oxygen is -2, nitrogen is +2. So for nitrogen, what happened? Actually, +5 changes to +2. So if +5 changes to +2, it means it gained 3 electrons. But like one nitrogen gain 3 electrons to convert from +5 to +2. But if 2 are there, 2 nitrate, so how many electrons? So it should be 3 multiplied by 2, so 6 electrons. So basically 6 electrons are gained by nitrogen. So this metal should also lose, because the number of electron lost should be equal to number of electron gained. So this metal should lose 6 electrons so that the nitrogen can gain 6 electrons. So if the metal if three metal atoms loses 6 electrons, so each metal will lose only 2 electrons. So what will be the charge if each, because this is for 3 metal. So 3 metal atoms are losing 6 electrons. So one metal atom will lose 2 electrons. And if one is losing 2 electrons, then what will be the charge on each? The charge should be 2 plus, or it will be +2. So B will be the right answer. Question 5, use this electrode potential to answer the following questions. Which of the species is strongest oxidizing agent? Oxidizing agent, help in oxidation itself, it is reduced. And reduction means gain electron. And the one which will have a higher positive voltage, like will have a tendency or a greater tendency to gain electron. And all the electrode potentials are always given to gain electron. So we'll check which one is having the highest positive. So see, chlorine is having the highest positive. So chlorine will have a greater tendency to gain electron. Cl2 molecule. Then which species would convert vanadium 4 to vanadium 3 under standard condition? So vanadium 4 converted into vanadium 3. Now these are the equations which are given. We will check each equation. So which equation vanadium 4 is converting into vanadium 3? Vanadium 4 converting to vanadium. So this is the equation. So if we use vanadium 2, like example, if a reaction include vanadium 2, so like equation, if I number the equation, so equation 1, and this is always there because this is a conversion of 4 to 3. So if this was there, then what will happen? Because this is because vanadium 3 to 2 or 2 to 3, this equation. So if these two are mixed together, the one which will have a higher potential, that reduction happen, and the one which is having a smaller, that oxidation happen. So one which reduction happen, the equation is as it is, like vanadium 4 convert into vanadium 3. But the one oxidation happen is actually, this will be the reactant, and it will lose electron and form vanadium plus 3 ion. So A will be the right answer, because like vanadium 4 will convert into vanadium 3, and the other species in which vanadium 2 will convert into vanadium 3, because oxidation happen, and oxidation is a loss of electron, means reverse reaction will occur for that. When we check, the A is the right answer, but why not B, C, or D? I will give you an example as well. See, if we use iodine, which equation use iodine? So this is equation 3 use iodine. So when we check the second equation with iodide, so this is a higher potential, so reduction happen here and oxidation for this one. So if reduction happen for this one, means here iodine molecule will react, not iodine. Like this will be forward, but and what happened? Vanadium 3 will convert into vanadium 4. So I mean, and it is obvious A is the right answer, but reason like B cannot be an answer. Same thing for chlorine or chloride. So for chlorine and chloride, the equation which is used here, which involve chlorine, that is the last. So what happened? As you see, if the chlorine is used, this is positive. So here reduction happen, because the one which is higher, reduction happens, so then oxidation. If reduction happens, so chlorine molecule will change to chloride ion, but oxidation happens. So oxidation happen means reverse will happen. 3 will convert into 4. That's why chlorine is not suitable. But what about chloride ion? Why chloride ion is also not suitable? So chloride ion, if we use a chloride ion, like the same equation will be there, because this equation include chlorine molecule and chloride ion. So here reduction happen, this one be oxidized. So first what it will do, it will convert vanadium 3 into vanadium 4. And then if it, because now vanadium 4 is there, this vanadium 4 will convert into vanadium 5. So it does not stop from 4 to 3. And the question is, as you can clearly see, this is a higher potential. So reduction happen, the other one, oxidation will happen. So this will be reduced, like chloride ion will convert into chlorine molecule. So oxidation happens. So 3 will convert into 4, not 4 converted into 3. Is it clear? Then which statement about the self electrode potential is true? So it is proportional to R ln K. So A is the right answer because it is ln K when we replace the constant in proportionality. So where we replace equal to and constant, we replace by proportionality sign. So it will be E proportional to ln K. So A will be the right answer. Then question 7, which of the following cannot dispropionate? So remember, like group 1, group 2, group 3, group 4, 5, 6, 7, and 8. Group, according to group 1, +1, +2, +3, -4, -3, -2, -1, and 0. But they may have +4, like this is a maximum, like it can have from -4 to +4. This can have from -3 to +5, -2 to +6, -1 to +7, and then 0. So even if it is having either one extreme, like very low oxidation or very high oxidation. So if it is having a very high oxidation, it can only be reduced but not oxidized. If it is having a very low oxidation, it can be oxidized, but it cannot be further reduced. So we have to check which one is present at its extreme. So the one which is present at its extreme, that cannot be changed. So here in a chlorine molecule, it is 0. So chlorine is group 7. So 0 can convert into -1. It can convert into +7. So oxidation reduction can happen. In a bromate ion, oxygen is -2. So 2 oxygen -2, and so it will be +1. So means this bromine is +1, and bromine belongs to group 7. So it can change. It can either change from +1 to -1, or it can rise to +7. So it can be oxidized or reduced, or it can occur a dispropionation reaction. For sulfite ion, each oxygen is -2, 3 oxygen -6. So the sulfur should be +4. So sulfur is group 6 element +4. So it can convert to -2 or it can convert to +6. So oxidation reduction can happen. But in a nitrate ion, each oxygen is -2, 3 oxygen will be -6. Overall charge is -1. So nitrogen should be +5. So nitrogen group belongs to group 5. One extreme it is occupying. So it cannot further increase more than 5. It can only be reduced. So D is the right answer for this. So which of these complex ions could exist as a stereoisomerism? Stereoisomerism here refers to cis and trans. So to be cis and trans, like different groups should be attached. Here this cannot be because all are identical. Here 5 are identical and 1 is different, so this cannot be. Here again 5. Why I'm saying this cannot be? Like example, if we have a cobalt. So if we have a cobalt, NH3 is there, then NH3 is there, then NH3 is there, then NH3, then H2O is there, and NH3. So this cannot have cis or trans because identical groups are there. So even if water H2O is with any replaced by any of the NH3, changes the position with water, again it will not have stereoisomer because it will have a different groups. But here this one, what can happen? Like if we have CO, maybe NH3 is attached here, NH3 is attached here, then NH3 here, and NH3 here, then Cl and Cl. So heavy groups are on opposite side, trans or Z, and heavy groups will be the same side, so it will be cis or E. Sorry, trans or E and cis or Z. So D is the right answer, that it can have geometrical isomer. Question 9, iron is suitable catalyst for reaction of nitrogen with hydrogen form ammonia. So basically what it do, these are heterogeneous catalysts, and how the heterogeneous catalysts work, they absorb the reactant molecules in the surface and reduce this bond strength. So it absorbs the reactant molecule and reduce the strength of a bond so that the bond can break easily and the reaction can occur at a lower activation energy. That's why we say the use of the catalyst lower the activation energy. In aqueous solution at pH 12, the amino acids glutamine exist in the form. So they always exist as a zitronine. Zitronine means like, because amino acids exist as a solid. Why? Because acids are proton donors. One side they have acid group, one side amine or a base group. So this acid will donate proton. It will get a negative charge, like proton or H plus is gone, and that H plus attached here. So one side will be positive, one side will be negative. And that's why that's the main reason they have an ionic bond and they exist as a solid at room temperature. So acid, why this is wrong? Because acid does not, the acid should lose proton and the amine part should gain proton. So in the question, like this is in a neutral solution, but now in the question they're saying aqueous solution has a pH 12. pH 12 means alkaline solution. So in alkaline solution, what will happen? Because amino acids contain amine group and they contain acid group as well. So because pH 12 means alkaline solution, so which part will react? Acidic part will react. When acidic part will react, it will lose its proton, so this will only get a negative charge. In a neutral, this same proton which is lost by the acid is attracted or attached with a amine group. But because they're asking for pH 12, so it means alkaline. So in alkaline condition, most of them C double bonded with O will be ions because they loses the proton or reactant. So B will be the right answer. Best method of separating a mixture of amino acids in a solution for the purpose of identification. So we use chromatography. Yeah, that's right. Then which molecule does not contain a chiral carbon? To identify whether it contains a chiral carbon or no, you have to draw the structure of each, and if the bonds are different, all the four bonds are different, it will have a chiral carbon. If bonds are identical, then it does not have a chiral carbon. So when we draw 2-bromobutane, so 1, 2, 3, 4, and 2-bromo means second position bromine is there. This will be CH3, this will be CH2, this will, so this is a chiral carbon itself, because four different groups are attached. 2-bromo, 2-methylbutane. So 2-bromo, second position we have bromine, and second position we have methyl. So when we check for this one, this CH3 and CH3, they are identical. Then Br and this all. So these two are identical. So if even two identical groups or 3 identical groups, so it means it does not contain a chiral carbon. So B will be the right answer. Same way we'll draw the structure of each, we can work out, but as B is the right answer, so I'm not going for all the structures. The question was which does not contain a chiral carbon. How many peaks would you expect to see in a low resolution proton NMR of? So we have to check the number of the hydrogen environment. If they're identical, we'll get 1 peak only for that identical part. So when we check for this, propanol is CH3, CH2, C double bonded with pentanone, sorry, not propanol. Pentanone is CH3, CH. So here this CH2 is identical to this one. So they will give 1 peak, A. And this CH3 is identical to this one, so that will be B. So there is A and there is B. A contains 4 carbon, B contains 6 carbon. So the ratio will be 2:3 for their peaks. But how many peaks are there? They have only 2 peaks. That is, one is due to CH2, identical. Another one is CH3. High resolution NMR spectrum of ethyl ethanoate contain. So how to identify? First, number of the peaks, ethyl ethanoate CH3, C double bonded with O, CH2, CH3. Now three hydrogen environments are there. This CH3, how many neighbors are there? Neighbor is 0, like does not contain any neighbor. So if it does not contain any neighbor, so always the splitting is n+1. So this will split into n+1, so 0+1, so it will give singlet. This CH2, next to this CH2 is CH3, and other side there is no. So 3 hydrogen in the neighbor, the splitting is always n+1. So 3 hydrogens are there in the neighbor, so it will be 3+1, so it will be 4, and 4 means quartet. So one of the peak will be quartet. So, and then the third one, this CH3, neighbor is 2, so 2+1, 3. So this will give triplet. So there will be triplet, quartet, and singlet. One quartet, one triplet, and one singlet. That's why C is the right answer for this. In methanol fuel cell alkaline condition, which are the following reaction occur at one electrode? The reaction occur at other electrode. So here, what is happening? Because it is losing, this is an alkaline condition, it is losing electron. So other one should gain electron. So to gain electron, A, B, or C all are gaining electron. D is a loss of electron. D cannot be an answer. But then what happened? Because this one, hydrogen and oxygen combine, take 4 electron and produce hydroxide ion. So when we check, because in a methanol fuel cell, there is no hydrogen involved. Hydrogen gas is not involved. Like here, they give you hydrogen gas, but this is a methanol fuel cell, so does not involve hydrogen. Then you are left with B and C. Why C cannot be an answer? Because C involve a proton, but they mention it is an alkaline condition. So in alkaline condition, they should be it's not OH ion which is it's not H ion which is responsible, because H ion is coming from acid. So that should be OH ion should be there. And second thing what happened, oxygen gain 4 electron and form hydroxide ion. So B will be the right answer. So, and C is incorrect because the conditions are alkaline. If the same question was there, acidic condition, then C should be the right answer. And D is totally wrong because the number of electron, if one side it is a loss of electrons, so this side should be a gain of electron. Question 16. The infrared spectrum of a compound which is having a molecular formula of C10, H12, and O2 includes strong peak in the range of 1750. So you will use a data booklet to identify the ranges here. So basically, one is due to C double bonded with O and one is due to CO. So which compound contains C double bonded with O and CO? That is ester. And one is due to C double bonded with O, and this 1150 to 1100, that is due to the presence of benzene ring. So one is due to the benzene ring, one is due to the C double bonded with O and O group. So means it should be ester and contain a benzene ring. So when we check the options, this is carboxylic acid. This is also ester. But here, the main peak or the strongest peak is due to benzene. Because when benzene ring is there next to carbon, like otherwise what happened? The peaks would vary. Like when we draw the structure, it will be C double, according to option D, it will be C double bonded with O and O. Then it will be CH2, CH2, CH3. So this is a proposed structure. So basically why A is not correct, because it is forming an acid, not an ester. It should be ester. And the C double bonded with O in a benzene ring, that is having a, so whenever there's C double bonded with O and a benzene ring is there, C6H5, then there will be this peak will be there, which is from 1150. So this is a peak which shows that a benzene ring should be next to C double bonded with O. So which option benzene ring is next to C double bonded with O? That is in D only. So, and this one is due to C double bonded with O, and this compound, when benzene ring is there next to carbonyl group, next to CO group. That's why D is the right answer for this. Which pair of a monomer could react to form a condensation polymer? Condensation polymer can form when carboxylic acid react with amine, or carboxylic acid react with alcohol, or alcohol react with another alcohol, or acyl chlorides reacted with, the acyl chloride is a C double bonded with ONCl. If they reacted with alcohol, that will also form, or if they reacted with carboxylic acid, sorry, alcohol, so that will also produce an ester. So condensation polymerization for 17. This is normal halogen and alcohol. Halogen and alcohol cannot undergo condensation polymer. These are alkenes. They can undergo polymerization, but not condensation addition. Here amine groups are there and acyl chloride. So amine will lose its H and this will lose its Cl, and the molecule can link with an amide or a peptide linkage. And here carboxylic acid is there and amide is there, not amine, amide. So carboxylic acid do not react with amide. It should be amine should be there, it will react, but not with amide. So C will be the right answer for this. So remember, carboxylic acid react with amine, that can form a polymer. Carboxylic acid react with alcohol, or alcohol react with another alcohol. In this question, sphenomaldehyde is a liquid that is slightly soluble in water but more soluble in ether. It decomposes below its boiling point. So when a substance decomposes below its boiling point, so we use normally we use a steam distillation. Like otherwise, we supply the heat energy and wait until the substance boil. So even before it's boiled, the substance converted into another, because chemically it changes. So for that purpose, we use steam distillation. So it can be extracted from cinnamon. The sticks of a cinnamon are grounded and mixed with water. Select the correct order of a practical technique which we obtain to sphenomaldehyde from a mixture. So we want to get this, and it is slightly soluble in water but more soluble in ether. So first what we do after formation, we'll use a steam distillation to remove that vapor. Then we extract with ether and distill out from ether. Like extract with ether means like use ether as a solvent and dissolve this sphenomaldehyde in ether, and then we will carry out a fraction simple distillation. So this will be separated from its other component. So A will be the right answer. Then which test result for cinnamaldehyde is not correct? So when you check the option, it contain aldehyde group is there, and it contain double bond. It also contain a benzene ring. So warm with acidified potassium dichromate, no change. It should change because it is an aldehyde. Aldehyde will be oxidized to carboxylic acid. So this is not correct. Warm with acidified solution decolorized, that's true because there is also a double bond is there, so it will form a diol. Then add PCl5 phosphorus pentchloride, no reaction because it does not contain OH group of acid or alcohol. And warm with toluene or reagent, that is also a positive result, that is true. So A is the right answer. Like A does not follow the it does not show the correct result. If it potassium dichromate, it will turn from orange to green. As aldehyde will be oxidized, so this will be reduced. So this was January 2019 paper.